Okay, I think, as promised, I think it's time to resume the session. Please get seated. All right, welcome back. We have second part of the afternoon session. We have 3 presentations. And the first talk will be given by Dr. Mohammed Al-Abdulmohsen. Dr. Al-Abdulmohsen got his, his master's degree from MIT and PhD from Boston University in system engineering. Dr. Mohammed got his expertise in AI and robotics area, and he's currently at Saudi Aramco, currently leading the IR 4.0 technology deployment. And I think that's going to be the scope of today's presentation. So, floor is yours.
Thank you very much. I hope everybody is still awake. It's going to be a short and sweet presentation, maybe with different flavors. Everybody talked in the morning and before the break about the theoretical numbers and magical equations. I will take you through different things. I will take you through business. I will take you maybe if you haven't been in any oil field. So this presentation is actually for you. So with that being said, let me start my presentation. So from the rollout of intelligent machinery to the vast deployment of autonomous reliability platforms, we were underperforming a fundamental transformation that's creating futuristic solutions. Let me say this in Arabic. Assalamu alaikum. My name again is Mohammed Al-Abdulmohsen. I'm from Khurais Producing Department, Saudi Aramco. Today, I'm very delighted to introduce you to Intelligent Khurais Center, or what we call it as IK Center, where the recently patented fuel gas optimization system is just a slice of a pizza or an example from the center capabilities. Ladies and gentlemen, this center is a true reflection of Khurais' strive for excellence, and I must say that the early strategic adoption of digital transformation roadmap coupled with the uniqueness of Khurais facility were the main levers for the mass deployment of substantial AI applications. And to demonstrate the uniqueness, Khurais facility was designed to be completely intelligent. It is equipped with more than 95,000 industrial Internet of Things devices, along with more than 6,000 kilometers of fiber optics under the ground. So we are basically creating a parallel digital world. In addition to that, we have 2 virtual data centers as well as a scalable network, which are paving the way to deploy and develop AI solutions utilizing available big data. With all this infrastructure, Khurais has the internal capability of utilizing the exceptional resources to unlock new business opportunities and roll out a wide spectrum of fit-for-purpose IR4 platforms that will be shown in the upcoming slide. Ladies and gentlemen, producing 1.5 million barrels of Arab Light as a maximum sustainable capacity, for sure, it requires a reliable system to ensure sustainable oil production, especially when the number of the equipment that we need to monitor more than 90,000 equipment. Because of that, we have adopted a creative, sustainable approach to maintain the healthiness of the equipment as well as our operations. This approach comes with the department or the company strategic vision that's embedding the asset performance part of our operations DNA to promote sustainability, which was cascaded into the department mission. That was also linked with our strategy to sustain the high efficiency to utilize technologies as well as innovation. Furthermore, this approach is driven by the need to have an end-to-end technology deployment from the well side all the way to the facility. Because of that, we have deployed solutions across the entire value chain. This objective is also advocating our persistent effort to further increase the asset reliability, utilize the massive, big amount of data to reduce emissions, slash the overall maintenance costs that are associated with the plant equipment, and most importantly, upskill the high talented workforce that we have in the company. Driven by all of that, the idea had came out to establish a digital hub located at the heart of our facility, which is called Intelligent Khurais Center, or as I mentioned earlier, it's IK Center. So, as you can see here, this is the center that I was talking about, which consists of integrated systems and platforms that provide real-time and predictive asset performance for machine behavior. Furthermore, it supports our vision and mission with the data-driven decisions during investigations, normal operations, and emergencies. In addition, it also acts as an incubator for innovative ideas. The center works through data-driven intelligence that's monitoring and analyzing the massive amount of data for rotating and stationary equipment. So how the data flow works? With the data flow, it's initiated from the field devices with more than 95,000 instruments that are distributed in the plant as a starting point. Next, the data go through the control systems until this data reach to the asset framework to feed the IK Center and AI platforms. After obtaining the massive amount of data, the center platforms will operate based on the developed numerical equations and algorithms that were built and integrated in-house by Khurais team. These algorithms were coded using different languages like Python, work together to monitor equipment healthiness, analyze the abnormal events in machines' behavior, and predict what will happen down the road, so our people will be aware and will know upfront what to expect and take the proactive measures. When it comes to energy efficiency, our operations used to deal with these issues after the fact, which causing the energy loss in many areas. For instance, energy KPI is computed from the yesterday's data, and we know if we are, and then we'll come to know if we are deviating from the optimal calculations for our KPI. The same thing is applied at different things, like the steam system, fuel gas, power, NGL, and you name it. Therefore, the concept was revamped by using the big data. So this is where we actually use the big data and AI on the field, where we developed a three-phase kind of a system to mitigate this challenge. Phase one consists of multidimensional Markov chain model to predict different correlated parameters, including fuel gas consumption, water injection rate, oil production, power, etc. The accuracy of Markov chain model was really substantial and excellent, where we reached about 95%. Phase two, which is given that the current production rate from both oil and water, we compute the optimal or the global optimal value for the fuel gas consumption, along with the power and also different parameters. This is step where we use the KNN algorithm to do that for us with an adaptive radius. Now it comes to the phase three, which is this is now where we put everything on a practical framework. Phase three, this part consists of the following, actually two stages. The first stage, by utilizing the results from phase one and phase two, to identify the potential operating gaps in terms of emissions, power loss, and dollar value. Where in the stage, in the second stage, we use the KNN value as an input to the optimization problem on the right-hand side, to provide or to recommend the operating parameters for our facility. So now it's like our operator sitting there on their desk, and then all of this calculation is being calculated, and then they see the end of this as an recipe for them or a prescription. Well, moreover, the center has helped us in achieving other astonishing results, including reducing the fuel gas consumption by more than 2 million SCAF per day, also increasing the energy efficiency by around 14%, and reducing the maintenance cost or slashing the maintenance cost by around 15%. Also, the center is equipped with different features such as advanced data analytics, process optimizations, failure prediction, and much more. However, for the sake of time, I will just highlight one actual use case that's being implemented on the plant with the failure prediction feature. So the feature is developed based on the machine learning and to be more precise, so by using Markov chain, multi-dimensional Markov chain states, and not only predict the potential failures, but also to avoid them at the first place. This feature was utilized in different occasions, and I would like to share with you the following example, where it was used as an early detection of abnormal vibration on one of the oil trains or gasps, where we avoided the high pressure gas compressor failure. This vibration trends did not, where the vibration trend did not reach to the normal alarming, but through the prediction model, the system captured the beginning of abnormal deviation from the normal profile, and considering different parameters such as vibration, temperature, flow readings comparing to their normal profiles. And an automated alert was sent to our team with the abnormal vibration, highlighting also the root cause or the potential root cause, where we highlighted in this example as the proximeter or probe as a potential reason for the failure. The team has immediately attended to the site to inspect the identified instrument and found that the looseness in the proximeter probe. The repair action took place, and the vibration reading started going back again to the normal parameters or profile. The failure prediction approach has also led to avoid the potential equipment trip with the potential reason of the instrument as a malfunctioning, and avoided also the potential burning of the gas, which along with the GHG associated GHG emissions, with an estimated also cost avoidance of more than $100,000 from this example alone. Furthermore, the center capability was also extended to cover the first factory acceptance test, which we did this as a virtual factory acceptance test in the company, and for one of our projects for the second phase saltwater disposal pump. The test was conducted with the vendor in Germany along with our central engineering in Dhahran. It's worth also to mention that since the full deployment of the center, we were able to achieve different awards at a corporate and international levels, where the award committees have commended not only being pioneer in the early technology adoption, but also in being part of the development. Additionally, 2 granted patents were actually earned, and one of them actually was during last week. However, this is not the end of our ambitious digital journey, as we are working to expand the scope of the technology deployment by deploying the latest proven technologies and also being part of the development cycle. And this hub is actually enabling us to do that, where innovation and the commitment of our workforce are the main enablers for us to do that. Also, we are leveraging the active collaboration with the academia, such KAUST, to enable us to develop edge technologies and solutions that will mitigate not only Khurais challenges, but also the challenges for the entire industry. With this, I reach to the end of my presentation. Thank you for listening, and I will be glad to answer any of your questions. Thank you.
Okay, we have time for questions.
Thank you, Mohammed, very much. Maybe I'll start with this question that I think it's been associated with AI since its inception with humanity, and it's, they've been worried about this, yeah? So will AI replace humans? And I think to your, application, you're applying such a toolkit. Have you seen operators' roles being redundant and not needed, shall I say, with this much of an upgrade? Or do you see more roles as being coming into the picture, human?
Well, it's a very tricky.
Are you reducing your workforce or not, maybe, shall I say? Or do
It's a very tricky question. It's actually, what we found from the field, that they are complementing each other. AI is just helping us in one side, and the human experience and the human interactions is helping us also on the other side. Because AI needs to have, from a practical point of view, it needs hardware and resources, right? So in order to maintain the healthiness of our infrastructure, we need different people with different background. So it's the AI itself, it's actually reducing the workforce in one area, but also increasing or introducing a new workforce in, I would say, in specialized areas. So it's a kind of, now we are shifting from having a stationed operator just to monitor the process 24/7. AI will do that for us, and we need them to be relocated to cover other areas in order to maintain the healthiness or to maintain the overall
efficiency,
system.
Reliability, all of these,
Yes. So that's now where we need to focus, our work, the focus of our workforce is to relocate them where we can, have them to support the maintenance of all of these new applications and systems.
Thank you. So good news, I guess, huh?
Any other questions? Right there in the back.
Thank you, Mohammed, for the talk. My question about the devices, the Internet of Things approach. You mentioned 95,000 devices connected. Why this number? I'm just wondering, is it a bottom-up approach where you have 95,000 sensors you want to digitalize to build an infrastructure, or do you have already an application and you want to use those devices, or is it basically a top-down approach?
Okay, that's a good question. It's actually, they are being deployed at the facility because we have a real-time control system, okay? And in order to do this on a real time, we need different IIoT devices to cover the whole value chain from subsurface, so from underground, all the way to the facility. So it was designed and built this way. The whole facility was designed. So now we are just leveraging the existing infrastructure to have an AI on top of it. So this is not a simulation, it's an actual deployment from end to end.
Okay. Any other questions? Yep, Jihad. Yeah. You can speak up.
Yeah, Mohammed, thank you very much for the presentation. Did you have any incident where AI made the wrong decision? Or the predictions was totally wrong and something?
Well, what we are using now, we are very conservative when applying AI. So now we are using it as a diagnosis. So it's not using it to take a decision whether to do this or that, but it's like an advisory. Because it could be like the first mistake could be like the last mistake for the facility, right? So this is where we need also a complementary, like the human judgment plus the AI, and we use it only to advise us how to operate and what is the optimal operating philosophy for us. So we are not taking the AI for a full autonomous. This is maybe like down the road, and this is our objective. Like we are selecting, developing technologies only to be, to help us to achieve the full autonomous. And this is maybe like still the market or all technologies are not ready to take us there yet.
Maybe that optimization can also be done by AI.
It could be.
Kind of related question, we're curious, I mean, especially like some safety-related issues, I guess you cannot tolerate
Yes, of course.
mistake by AI. So what is the kind of general guideline behind adaptation, decision point?
Okay, so basically the accuracy is one of our key factors. Like, like the prediction, the best prediction model, it will come with uncertainty part of it, right? And as if you were like riding a car, and if I told you that this car, okay, at 100 kilometer speed, it might work with a certainty of 99%, right? So you will not accept the 1%. Similarly to the oil and gas industry, 1% is too much for us to accommodate. So all of these will be enable all of these algorithms and all of these discussions that we had in the morning just will bring us one step closer to our autonomous goal. But safety is always remains the priority number one. That safety of our people is also is always remains the highest or the most important thing in our company. Maybe till the time to have a full autonomous from end to end. This is maybe we will rely 100% on the AI, but this is not coming soon. Maybe because we are very conservative there.
Thank you so much for interested use cases. I would like just have a small curious question. These solutions deployed within OT network or IT?
Okay, this...
and how you deal with this convergence and conflict?
Okay, that takes us maybe to typical Aramco question, but it's well, we have different networks. In Aramco, it's actually segregated into many different networks. All of these technologies are within the facility, within the premises themselves, so they are not connected to IT. However, they are connected to the control systems. So they are connected to the DCS or distributed control system for the actions, but they are far from IT. And because we have like a gap, a data diet, it's one-way communication. So that, to answer your questions, all of them within the premises.
I have a question. Sure. Thank you very much for the presentation. I would like to ask about the complexity in the system, because you are trying to reduce emissions and gas flaring, but on the other hand, you have the reservoir management. So you are producing from so many wells, and some wells has electrical submersible pumps. So how do you convince, for example, petroleum engineers that we need to reduce production from a couple of wells, but sometimes when you reduce the production, you actually hurt some wells. So, for example, if you lower the production, you may not regain the same production if you increase that. So how do you manage this complexity between you and reservoir people?
That's also another interesting question. When it comes to reservoir in general, we adopted another application. It's an advanced process control system. It's for the first adoption of the APC system in the world for the conventional oil field. So actually, all our submersible pumps and ESBs are being controlled completely with the APC system. So they are with with flexible speed and variable speed, and we can control them based on the production target. We can control their speeds, and that's also in alignment with the R&D. So R&D, they just tell us how much that they need to produce from each well, and we do that in a very optimal power manner. That's through the APC system, and that it takes care of the power kind of operating parameters for each ESB individually. We are talking about 1,000 plus ESBs in one reservoir, and if we reduce the power consumption by 1%, you can multiply this by 1,000. So we are talking about, it's a big reduction in terms of power and emissions as well.
Okay, any other questions? We still got some time. But if not, let's thank our speaker again.